guess I'm on Canvas now.
Yeah, everyone's on Canvas too. Okay. Human population growth curve. Okay, so notice how, looking at this here, what type of growth curve is it? Remember, there's two types of growth curves that we talked about in the last time? Logistic or exponential, right? If you're looking at this overall total population, it's exponential. But I can see how you're saying the average. Yes, this very good. This average annual increase is becoming more logistic. I agree, kind of thing. But overall, we're having more births than deaths, and hence the reason why we have this increase in population. So this is just showing you a history of this human population growth. So in the 1500s, way back in the day, even older than me, this is when you have about 480 million people that are available, and then there's very slow growth during this period of time. So the rate of births is about the same rate of the amount of people dying at that period of time. This is due to parents at this point in time. They have a lot of children, but at the same time, the mortality or the amount of deaths that is occurring was very high as well. So that's why it's equaling the amount of births and deaths occurring. In the 1800s, we have a little bit more advancements in nutrition, sanitation, and also later in medical care as well. So this is what is starting to the cause of this increase here, as you can see from the 1800s onwards. So, of course, the amount of deaths is going to decrease, and at this point in time, the birth rates remains the same. In the 1900s, notice how the population increase now is drastically gaining more and more. This is because of improvements with what we just talked about, nutrition, sanitation, and healthcare. Okay, and not only to the developed countries, but also to developing countries as well. These third world countries where they are getting improved nutrition, sanitation, and healthcare. Okay, so the amount of death rate is decreased, like we talked about, due to improvements in nutrition, sanitation, and healthcare. But not only that, there's an increase in the amount of birth rates as well now, and hence this explosion of population growth now. Since the 1980s, there is somewhat lesser of a growth, as you can see this graph here, this average annual increase has decreased somewhat. This decrease is partially due to the contraceptives that are introduced after the 1980s, and also so that decreases the amount of birth rate. However, this only occurs in the developed countries, meaning that still it's pretty high birth rates in the developing countries at this point in time. So we talked about age structures. Remember, age structures help us look at the different ages for a particular population. And not only that, it helps us predict the population's future growth as well. We have these particular bands here. These orange bands on the very bottom is the ages before puberty occurs, before they become reproductive ages. So people below the teens, below the teens kind of thing. And over here in the green is the reproductive ages. So all the way until like about 45-ish. And those in the blue here are the people who end up not being able to reproduce. We're talking more about women than men, because the men tend to still have the function of reproducing and bearing children. I mean, not bearing children, but Anyways, you understand what I'm saying. Looking at this particular graph here, on this bottom here, this is a age structure of Mexico. And so here we have, as you can tell, well, tell me about it. What is happening from each graph as it progresses further and further?
There is an increase in medicine, nutrition, so that people are living longer.
Okay, okay, I can see that. Like, because of increase in healthcare, nutrition, sanitation, we tend to have an increase. The lifespan of people tends to be longer, so that why we have more people in their older ages. Okay, that's one way of seeing it.
The
Very
death
good.
rate is decreasing while the birth rate is staying the same, I guess.
Okay, that's part of it, right?
Well, yeah.
Yeah, the death rate is decreasing, causing the population to stay this, it continues to increase as birth rates increase. Good.
Does this also mean that they're reproducing later years?
Yes, in some sense, yes. Not really. They're not reproducing any more after their reproductive ages.
Right.
But notice how the amount of population here on this 1985 graph here on the very bottom, there's a lot of people, right, in their pre-reproductive years. About 15 years from now, they are in their reproductive ages now, right? So there's a lot more people in their reproductive ages to reproduce even more people. Does that make sense?
Yeah.
So that's why it's starting to becoming more and more due to the amount of there's a lot more children here. So when they grow older, since we have a lot more children, now they can bear their own children. So they're going to end up producing even more children. And so this group here becomes older, and they tend to continue to have this wider or more population. Does that make sense?
Yep.
Versus here, this is an example of the United States now. And how does it differ, or in what ways is it the same or differs, kind of thing?
Fewer children, fewer age groups in their reproductive years.
Okay, there's fewer children in their pre-reproductive years. Okay, good.
Not the same number presently.
And so when they become in their reproductive years, there are fewer children. However, they're going to still reproduce, possibly a greater amount of numbers. And so here we have more children here at this period of time. And so, in some essence, like average, it depends on how many children you reproduce too, depending on which nationality you are. Like, for instance, like China, they have this one-child kind of law kind of thing. Although it doesn't really turn out to be what you would expect. Like, what kind of graph would you expect in that kind of one-child law kind of thing? Yeah, it would be an inverse triangle kind of thing, right? Kind of thing, where you have very few on the very bottom here, or less so compared to the amount on the top. However, in their age structure, it doesn't really show that because although the one-child law doesn't mean that they restrict you, they just give you a lot of benefits for having one child, if that makes sense. So people still are having more children for those who don't end up taking advantage of those benefits. So.
Do they have contraceptives in China?
I'm sure they do,
But I mean, like among like the common
Oh, I see. I don't know. Like in the rural areas and stuff, maybe not, and that's possibly why they tend to have more children. That could be a possibility.
But it might be less accepted as well.
Yes, it might be. Well, oh, you mean having more children or less?
Like no, like culturally, like contraceptives would be less.
Oh, accepted. Yeah, that could be a reason why
Which would be
too.
a factor for the bottom.
I think.
Which would probably be a factor for the bottom.
Bottom
because
here.
it's Hispanic.
Yeah.
They usually start early and then
Yeah.
at least back then. It's children around.
So I mean, for example, like if it's that inverse triangle, right? If you have an inverse triangle, what do you expect like their population size in the future? To decrease, right? In population size. Very good. Okay. So one of the side effects of increasing the amount of population is that we need a lot more things to help support this new population. So we have to increase the amount of schooling, right, involved with it. So there's going to be a lot of these children who need schooling to be educated. Not only that, we need to have a lot of jobs as well, because as these children grow older, if we have a lot of children to begin with, at some point in time they're going to seek jobs, and so we need to have a lot more employment. And infrastructure meaning like things like roads on, like see how much traffic there is now compared to like 10 years ago or 20 years ago kind of thing. So infrastructure also needs to be increased. And of course healthcare, right? At some point in time these people are going to retire and they need to be offered Medicare or Medi-Cal and stuff like that to help support these elderly people. So does that kind of make sense that this increase in amount of population, we need to increase all these other things to help support that higher population?
Is that what's going on right now with the baby boomers?
Yeah, with the baby boomers, because we have, and I think you kind of see that here. Over here is the baby boomer generation here, and these are the children of the baby boomers here. So as they continue, so over here, I think they're around this area here. Notice how that huge increase in amount of people here, because these are the baby boomers here. So in 2010, they're all over here, close to retirement, and from then on, they will be retired here. So we need a lot of support with financially and stuff like that. And so there's this fear that we don't have enough taxes and stuff to support that and stuff like that. It goes into politics and whatnot, but I'm not going to go in there. But I'm just saying, like, population-wise, this is what we see.
So at that point in 2035, that's like the peak. So is it going to go down because now that the baby boomers aren't going to be living so much after that?
Well, not really, because if you see the amount of reproductive year individuals here, it's pretty wide in comparison to where the baby boomers is, right? It's even wider than that. So we're going to continue to increase the amount of children that we have, unless we do something about it somehow, like control the amount of children we produce or something. Yeah, I mean it's a problem. It's a future problem. It's a current problem that will result to future effects, and it's something that we should be aware of at least, to be more conscious about our own decisions in our own lives, kind of thing. So of course, with population increase, we're going to leave a more ecological footprint. And the question is, what is the carrying capacity of humans? What is carrying capacity, period? Anybody remember what carrying capacity is? We're talking about the logistic growth, right? When we're talking about the logistic growth model, it looks something like this. What is the carrying capacity? It's this point over here where the maximum population is located at, right?
Maximum population size and environment.
Yeah, exactly. So, what is the carrying capacity? That is a question that we don't know the answer to. Have we actually reached it? Have we overshot it? Things like that. So, for example, we do rely a lot on agriculture, and notice how in agriculture we have a lot of livestock, and livestock they tend to, if we don't maintain it well or sustainability, they tend to overgraze, as shown over here on the upper right hand corner. If they overgraze, then that land is going to be useless from then on for many years. So overgrazing from livestock can make some particular land unstable, unusable. The amount of water used because of the increase in population, it will also increase. That's going to cause the rivers and groundwater to dry up. And how much of that do we have on this earth, kind of thing. Global warming will also cause some food shortages due to temperatures being too high to prevent the growth of certain plants. And currently, we already have a lot of people who are malnourished or undernourished. So, and we're as the population continues to grow, we're going to have less and less resources to help feed and provide for the population. So what the ecological footprint is, it's just the amount of land that is and water being required to use to be able to provide an individual or nation for how much they consume. So if we divided everything equally, all the land on the earth equally to all the people on the earth, it'll give us 2.1 hectares per person. So 1 hectare is about 2.47 acres of land. Okay, so that's if everyone's equal. I'm just saying, like the amount of land that will sustain the amount of energy that a person produced, average person produced, will be 2.1. Okay. In 2006, on average, a person has 2.6 of these global hectares that that they use. So meaning that we've actually went over the amount that the planet can be able to provide for us. Okay. So, and then in the U.S., one person tends to use 9 global hectares. Okay. So it means that we're unevenly using up a lot of the land than what a person, that the Earth can even provide for us. Over 4 times the amount. America. So, and this is just showing you the intensity of it. So the darker the color in this particular pictograph here shows the more global hectares that they use, the more of an ecological
Is South
footprint.
Africa the darkest one?
South Africa, that's
Australia.
No. South Africa.
Oh.
Or no, that's
South America.
South
That's
America, yes,
America.
sorry.
South. I don't know. I still think the U.S. is the darkest, maybe. Yeah, Alaska is meaning that it's part of the U.S. You know, kind of thing. Not necessarily Alaska themselves, but since they're part of the U.S. there.
The other, okay, Hawaii's right, those guys.
Wow.
Forgot about
Where's
those
white?
White, yeah, I guess they don't use that much, you know. So we have an uneven share of it. We have the lion's share of it. So we do have an impact on biomes on the Earth. 75% of Earth's biomes have been altered somehow by humans, mainly for agriculture and also for development too, to help house us and whatnot. Yeah, for agriculture and development. Okay, so the way that we've impacted forests in particular, we cut down the forests to help us to do agriculture, to grow food. Due to the growing population, we have to have more food sources. So what do? We cut down forests to make places for us to plant food. And so it does make unsustainable agricultural practices potentially. So like the overgrazing that we saw earlier on. Also, we end up cutting down forests to provide biofuels as well. Logging was also a factor at some point in time, and also currently probably still is a factor. Mining as well. And air pollution. Air pollution, the amount of air pollution we produce will affect the plants around us. So there are some benefits for forests. They do help benefit us by help purifying our air and water. So we cut down more of these forests, they're not going to be able to purify as much water and air for us. It also helps provide nutrient cycling that we were talking about before, where it helps having decomposers around to provide nutrients for other plants for us to be able to utilize and consume. Also for recreation, right? This is as well, but it is a benefit. But yeah. Okay, so seeing this here is part of the rainforest over here. In 1975, as you can see, the rainforest, very remote, not really touched by humans. Here in 2001, we created these roads and everything going through it, and basically fully looks different from what it was in 1975. That's right. There's also a human impact not only on forests but on water too. We do pollute it by having these runoffs from fertilized farms and livestock, and also industrial waste as well. In Las Vegas, what can you tell me about these pictures?
It didn't stay in Vegas.
In 1973, the amount of... Okay, the green is more satellite photos, so that's actually like vegetation and grasses and trees and stuff. Vegas. So there is more what? More vegetation, more plants, right? You might be thinking, hey, that's actually a good thing, right?
Well, how's that?
Yeah?
And that's bad.
Okay, what is Vegas's weather in general?
Awful.
Very hot, right? Very dry and stuff like that. Okay, so if they're in a very dry and hot area, how in the world did you get more vegetation there?
Is that like algae?
No, it's not algae. It's
No,
actually...
like it's not like a picture of a lake or anything, right?
No, this is actually a view of the city itself. Yeah, a sky view of the city. Satellite view of the city.
I don't know where that's at.
Weird.
Okay, so if it's very, I don't know, maybe if you went to Google Maps and it might look like that. I don't know.
Let's see.
I don't know. Anyways, this is for your textbook. Okay, so what I'm trying to get at is like, okay, so there's this much vegetation. You might think, okay, that's a good thing. But we know that Las Vegas is very dry and hot. So how is vegetation growing in this environment? Lawns. We're providing water in this location, right?
More than average.
Yeah, to sustain this, right? We're actually putting a lot of water to be able to cause this vegetation to grow. Where are we getting that water from? Yeah, from the Rocky Mountain, from groundwater and stuff like that. So what are you going to expect is going to happen to that water? So water use is increased due to the population increase. Lake Mead is the reservoir from the melting snow from the Rocky Mountains. And this is where Las Vegas gets its water. Notice how at one point in time, the water level is all the way up here. And now it's decreased to there. Okay, this is massive amounts of water. It's not just like, a drop in the bucket kind of thing.
Can you go back? Oh, I bet you're done with that slide.
Oh, no, not yet. You wanted me to go back where? Just here?
Yes, thank you.
Oh, sorry, I went a little too fast. So, also due to kind of global warming, there's less snowfall occurring. So that's one reason why we don't have as much water level in Lake Mead. But also the amount that we are consuming, right, to help sustain the greenery within Las Vegas. So yeah, a problem there because this is not an unlimited supply of water, right? So. For greenhouse effect. Okay, so greenhouse effects, we've heard about it. We talked about it. So this is when this global temperatures increases due to greenhouse gases. And greenhouse gases, what they do is they absorb the heat from the sunlight. So sunlight comes down, gets reflected off the land and water of the earth. So it goes back into the atmosphere. The greenhouse gases, they trap the heat and retain it here. And so if we have more greenhouse gases, what do you think is going to occur with temperature within Earth?
It's going to rise.
It's going to rise because it's absorbing that heat, right? So there is some heat that does escape into space, though. So the natural greenhouse gases is carbon dioxide, water vapor, and also methane as well. So these are the natural greenhouse gases. Some synthetic greenhouse gases are the chlorofluorocarbon. And this used to be in some of the spray cans, probably even before any of you were born. But when I was a kid, they used this frequently in many of the spray cans. They're not as used as frequently now, thankfully, because these are the hairspray cans and stuff like that. So within the past 100 years, it's increased by 0.8 degrees Celsius. That doesn't seem like much, and it may not be much, but you also want to take note that 75% of this 0.8 degrees Celsius increase was due within the last 30 years. So that's a kind of significant increase for the amount increase in such a short amount of time.
It's a hoax.
There is a projected increase that it will increase by 2 to 4.5 by the year 2100. If we continue at this rate, type of thing. So most scientists, they believe that human activities are the cause of greenhouse gases, and this is due to, we said earlier, agriculture, right? Agriculture, cattle, including humans, they produce carbon dioxide just by breathing, right? And also some methane by flatulence, or farting if you want.
That's not the reason, really.
And yeah, landfills contribute a lot with methane as well, with the amount of bacteria that there are in landfills. And of course, the more people you have, the more trash you have, so there will be more landfills as well. Also, the burning of wood and fossil fuels, including oil, coal, and natural gas, also contributes to the increase in these gases.
What are free radicals?
Free radicals? Oh, I see. The free radicals are just these unpaired electrons within atoms. And usually,
Chemistry.
yeah, there's more chemistry, but it takes away some of their electrons from your DNA or from parts of molecules within your cell, and that's going to cause mutations and stuff. Okay, so the amount of carbon dioxide concentration for about 650,000 years, carbon dioxide levels have been less than 300 parts per million. So very few, very minimal amount of carbon dioxide. And now we have about 390 parts per million, and it's still going to continue to rise. So now we're over here at 390 here. So it's increased a lot. Okay, over here I messed up, but I don't know what I wrote there. But photosynthesis, from what I remember, it helps decrease the amount of carbon dioxide concentration. And we said that producers, through photosynthesis, uses carbon dioxide and water to end up forming carbohydrates and also oxygen. So it's using this equation here. You don't have to memorize this equation. Just overall know that plants, they utilize carbon dioxide. That's how it takes away carbon dioxide from the earth, and water to make up. This is glucose, which is a carbohydrate, and it produces oxygen at the end. Later on, when we go into photosynthesis, you'll need to know this more in detail. But know the generalizing what's happening here. Of course, if you deforest the area, you're not going to have as much oxygen, very good, because it can't go through photosynthesis. You don't have as much photosynthesis as well. So it's not going to use that much carbon dioxide. So you're going to retain carbon dioxide in the air. If you retain carbon dioxide in the air, what's going to happen? It's going to absorb more heat, right, to cause an increase in temperature. The water bodies, they also help decrease the amount of carbon dioxide concentration. So this is when you increase the amount of carbon dioxide. So the more carbon dioxide that the ocean absorbs, the more acidic it becomes. Next week I'll kind of provide a demonstration of that. So what this is trying to say is, if there's a lot of carbon dioxide in the atmosphere, it's going to absorb a lot of that carbon dioxide more and more. And pretty soon, the amount of carbon dioxide that is within the water is going to become acidic. It's due to this particular equation here. This is just carbon dioxide with water makes this thing called carbonic acid. And this carbonic acid is going to produce a lot of hydrogen ions. This is what's the thing that's causing things to become acidic. If it becomes acidic, what is going to happen to the aquatic, fish, and also the aquatic plants as well? It might kill them, yeah. So the carbon footprint is the amount of greenhouse gases that is produced by a person. So to try to reduce the amount of carbon footprint, what are some of the things that you'll suggest? Turn off the lights if you're not using it. Very good. Okay. Okay, turning off, shutting down faucets. In some sense, it does indirectly save the amount of water to be able to help absorb the carbon dioxide in the air. So we already said turning off lights, TV, electrical appliances. So not only does it turning off the lights, but unplugging electronic devices as well. So. Meaning that if you're not using it, like right now you're charging your laptop and you're actually using your laptop. But something like cell phone chargers, if it's not charging anymore and you just leave it plugged in, it's using some electricity by doing that. Even if it's shut off, like consoles, if it's shut off and you see that red light there, it's still using up energy to have that red light glowing and stuff like that. If you unplug it, then it's not going to use up as much energy. Audio equipment as well. Also using energy efficient light bulbs. So in this particular case, we used to say let's use fluorescent lights and stuff. Now it's going even more advanced. So if you look at the the parking lot, right? They changed that all those fluorescent lights into LED lights now, so it uses up less energy. And then, I don't know. Have you guys noticed the change in the parking lot? No, this is the same. Yeah.
Status quo.
They're lights. It's just lights.
We're on the way out.
I can see where I'm driving.
We've got to go.
All good.
In a hurry. We can see our way out.
Transportation, having public transportation helps save the emission of carbon monoxide and whatnot. And also, like, if you were able to carpool with others and whatnot, it will also save. Of course, reducing, reusing, and recycling. The best way to help lessen the amount of carbon footprint that we have is reducing the amount of things that we use, right? That way we don't have to have things to be produced for us to use them. Of course, reusing things will help even, not even more so, but less so. If you reduce the amount, then they don't even have to produce that product. If you reuse that product, then they don't have to produce the same product again. Recycling is helpful, but they still have to produce the product. You're not reusing it, but you're just putting it so that you don't have to use as much energy to make the same product. So, because reducing is the most beneficial, reusing not as beneficial, but still more beneficial than recycling. But recycling is still beneficial than not recycling, right?
Does the recycling take a lot more energy than it would take to produce an item?
I think it depends on what it might be.
Okay.
Yeah.
I heard the temperature, you have to melt everything down.
Yeah, it might.
Higher energy than it would cost to produce it.
Yeah, but I guess also depending on quantities as well, right?
Yeah.
Yeah. So I think there's a lot of factors that are involved.
For recycling anyway.
Also, yeah, go ahead.
Okay. Well, I guess here in Pasadena they're doing the whole no plastic bags.
Oh.
So they charge like 10 cents for each month. I use those trash bags for my trash at home. So to use something like that, I'm gonna have to go buy trash bags. Kind of the same thing, isn't it?
No, I mean, I have my own opinions about that kind of stuff, but I'd rather not really state them and stuff like that. But I mean, it could.
He's being recorded.
There could be other. There might be other reasons behind that. That thing happening.
Yeah.
Yeah. I don't know for sure, but I think that there might be other things happening in regards to that. Okay, what you eat also helps lessen your carbon footprint. And we talked about earlier about cattle, right? So cattle, they release 20% of the methane emissions that are within the earth, just because of the sheer amount of cattle that we have. So, of course, if you don't eat as much cattle-related foods, like anything beef-related, or steak, and egg, they're not going. They won't. If they won't be we're not going to end up having this type of agriculture to sustain them as well. Plus, you talked about how overgrazing occurs and whatnot too. So, yeah. Of course, eating locally will help in some certain aspects as well. Like if you eat local foods or local planted vegetables and whatnot, then they don't have to carry it from a very far distance. So to truck it all the way over here. So that's going to reduce the emission of that carbon footprint as well for transporting that. So eating locally as well. I think that's pretty much it for this one. Acknowledgements and the different pictures I ended up using for this particular slide. And that's it.
Professor, there was a slide in between human impact on forests and